Alright, I am recording this video to answer questions over the homework over parametric equations. I don't think you guys should have had problems with the first page, so this page here, I don't think you should have any problems. The answer key is online, or this for that matter, or this. What I do think we could have had some problems is maybe on the projectile motion problems number 1, 11, 12, 13, and 14. So I'm going to work on 11 and 12. They're going to be great examples, and then I believe you can get 13 and 14 on your own, okay? Alright, so I kind of already have this all worked out, so I'm just going to do it on the equations for a projectile motion is that x of t equals to initial velocity times the cosine theta times time, and y of t is initial velocity times sine theta times time, minus 16t squared plus h. I want to talk about that h. H, that's the initial height, which means that you won't always start at the ground. So for example, if I'm a football player and I'm going to throw a ball, I'm 5 feet tall, so the ball is probably going to, initial height is going to be around 5 feet, and then I throw it, and then you can kind of grab the motion of the football from there. So that's what I mean, okay? But for problem 11, it says that you have a projectile launched from ground level. So if it's from ground, that means that your h is 0, okay? And then it says use the given information to find the maximum height in the range. When it's talking about range, it's not talking about what you typically think that it's like the y values. It's talking about, when we're talking about motion, it's how far the ball has traveled horizontally. So that's when we're talking about the range, okay? So here's the information given for problem 11. We know that theta is 60 degrees, and we know that the initial velocity is 88 feet per second, and obviously we know that h is 0, okay? So first we're going to write down their equation. So that means that x of t is going to equal to the initial velocity, which is 88 feet per second, times the cosine of 60 degrees times t. And the equation for y is going to be 88 times sine of 60 times t minus 16 t squared. And the height is 0, so that's plus 0, so I'm going to leave it out. Let me zoom in a little bit, okay? Alright, so then we need to find two things. We need to find what is the height, the maximum height, and what is the range, okay? Alright, so here's what I'm going to do. First, I'm going to show you how to use your calculator to help you out. I want you to turn it on, and the first thing I want you to do is I want you to go to mode. And if you go down to mode, there's going to be 4 options. One of them is function. One of them says PAR, that stands for parametric. POL, which is polar, and SEQ, which is sequence. Okay, so we're dealing with parametric equations, so we're going to get PAR, hit enter, and when you go to y equals, then you're going to get, sorry, I had already worked some problems out. You're going to get the following. You're going to have a space for x and then space for y, which makes sense because you have a function of x of t's and then y's of t. So here's what you're going to do. You're going to plug them in. So we're going to say 88 cosine of 60 t, and then on y, I'm going to put 88 sine of 60. I'm sorry, theta. Time minus 16t squared. And I'm gonna hit graph. All right, let's talk about this. You're expecting this to look like a curve, okay? This obviously does not look like a curve. It is your job to manipulate the window in order for you to see the entire picture. But you may ask yourself, well, how am I going to know what x and y values I'm going to need? Well, that's simple. I want you to go to the table. Okay, let me start the table at 0. So, and then just kind of look around. So at time 0, you're at 0, 0, which makes sense. That's when you're launching the whatever object it is that we're launching. After 1 second, it's 44, and then the height, 60. 88, look, that's the height, 84. So it's looking to me, just by looking at this, is that the height, the max, the high 80s, okay? And then it starts to decrease, and eventually it gets negative. Well, if we're talking about an object, it can't really go underground. So I want you to compare it to what you got on your x values, which is, it becomes negative at around 220. So here's what I'm going to do. I'm going to go to my window, my table set, and I'm going to leave the t values alone and the t step. But I'm going to say that my minimum x value, well, obviously since I'm launching, I'm just going to say 0. Okay. But my maximum, remember how it went negative around 220? I'm just going to say 250. Why not? Okay. My minimum y value, I'm going to say also 0. Okay. But for my maximum, remember how the number got to the high 80s and then it started to go down? I'm going to say around 95, just to kind of help us out. So now hit graph. And what you look at that, now you kind of have an idea of what this thing looks like. Okay, and you also have a kind of an idea that your maximum height is going to be here, and it's going to be around a high 80 something number. Okay. However, we need to figure out the range, which will be this point right here when the height is 0. Do you agree? So if your height is 0, that means that your y is 0. So here's what I'm going to do. First, I'm going to find my range. Okay. And the way I'm going to find my range is by plugging in a height of 0. So in other words, I'm going to let y equal 0. So I'm going to say 0 equals 88 sine 60 degrees of t minus 16t squared. And this is a quadratic, honestly. You have a t squared term and then you have a t to the first power. So you're solving for t. So here's what we're going to do. Once we find the t, that's the amount of time that it took to hit the ground, and we're going to plug it into the other equation to find out the horizontal distance. Okay, so here's what I'm going to do. I'm going to factor out a t, so this becomes 0 equals t times 88 sine of 60 degrees minus 16t. So now you have two factors, so we're going to say t equals 0. And then we're going to solve for 88 sine of 60 minus 16t equals to 0. So we want to solve for t. So if we want to solve for t, then we're going to subtract 88. So this becomes negative 16t equals negative 88 sine of 60 degrees. And t equals to negative 88 sine of 60 over negative 16. Alright, that's going to be an approximate. So here's what we're going to do. We're going to go to our calculators. So I'm going to quit there. We're going to plug this in. Alpha y equals enter. Make sure that you are on degree. So here I am on degree, so I'm going to get out of there. So it's negative 88 sine of 60 degrees over negative 16. Okay? And then I'm going to hit enter. Alright. So it is telling me that t is approximately 4.763 seconds. So it takes, let me go back to the graph, it takes approximately 4.763 seconds to get to this spot right here. That's not really what I was looking for. I'm looking for the distance. But let's look at the equations. If you know the time, then you can plug in that t value here and you're going to find the horizontal distance at that time. Okay? So what I'm going to do to be exact, remember how we plug this into the calculator? I'm not going to use an approximation. I'm actually going to store this. So remember, to store in the calculator, I'm going to hit STO and I'm going to store it in t. And I'm going to hit enter. So then what I'm going to do is I'm going to plug this into the calculator. So x of 4.763 equals 2 times 4.763. So that means that x after 4.763 seconds, the ball has traveled this much distance horizontally. So let's go ahead and plug that in. We're going to say 88 cosine 60 degrees. And we're going to put t because we had already stored that value, and we're going to hit enter. Alright, so here's what that means. At this time, this has traveled 209.578 feet. So that is going to be our range. The other way that you could have done this is that if you actually go back to the graph, remember how back with rectangular equations you could do second, trace, and you have a menu to calculate minimum and value maximum? Well, unfortunately, you don't have that. But you can calculate a value. So what I'm going to do is I'm going to hit option number 1, and you got to give it t a value. Well, remember how you have stored the t value? If I hit t, and I hit enter, it's going to give you the horizontal distance right there and the vertical distance. So after 4.763 blah 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 seconds, it is going to be at 209.578 feet horizontally and 0 vertical. Cool? All right. So now let me ask you. This is remaining at a constant velocity, right? It doesn't say that it changes. So if it took that long to get here, wouldn't you agree that the highest point would be the midpoint? All right, or half the time to that it took to get from the starting, which was 0, 0, to this point right here. Right? So here's what I'm going to do. I'm going to get out of here, and I'm going to say, remember how we had t stored? I'm going to divide t by 2. T divided by 2. So half the time would be the highest point, which would be 2.381 seconds. So here's what I'm going to do. I am going to now store this new value into t, and I'm going to go back to second trace and calculate that value. So when I hit t, then your calculator is going to give you the highest point, which is this one right here. That's going to be the horizontal distance, but you don't care about the horizontal distance. You care about the vertical distance. So that means that the vertical distance, or the maximum height, equals, according to your calculator, to 90.75 feet. And that's how you're going to do this problem. Number 12, it's the exact same thing. You can try that on your own, and the answer key will be online. I'm going to do number 13 with you because it requires a little bit more algebraic skills on there, which I believe you do have, but I just want to kind of share with you, okay? So let's do 13. 13 is very similar, so let me get another piece of paper. 13, it says that you have an archer releases an arrow from a bow at a point of 5 feet above the ground. So now we know that h equals to 5 feet. The arrow leaves the bow at an angle of 10 degrees, so theta equals 10 degrees, with the horizontal and an initial velocity. So initial velocity v naught equals 240 feet per second. We're going to write a set of parametric equations that model the path, and then we're just going to take it step by step. So first equation, x of t is going to be 240 times the cosine of 10 degrees time. Y of t is going, which is 5 feet plus 240 sine 10 degree times t minus 16t squared. Okay, this is supposed to be sine. Sorry, it looks horrible there. Alright, so there's our equations. It says, assuming the ground is level, find the distance the arrow travels before it hits the ground. Ignore air resistance. So in other words, let's kind of graph this on our calculator so we have an idea. So we're going to go ahead and clear this ones out that we had before. Alright, so here's our x, which was 240 cosine 10 degrees times time, and y is 5 plus 240 sine of 10 degrees times time minus 16 times square. Let's hit graph. Alright, and we can kind of say this. We're going to have to do the same thing as the previous problem, which is kind of look at the table values and manipulate this, okay? Looking at this and looking at the numbers, it looks like the highest point is going to be higher than 30. So when I go to my window, I'm going to change my y value to somewhere around 40. Okay, let me go back to my x. Before it gets negative, it's at around 700. So that's what I'm going to do. I'm going to put my x window. So I'm going to go back to my window, and I'm going to put my maximum value for x around 700. Let's hit graph. Fantastic. There we have our window. So what we're looking for is this point right here. Okay. Again, your calculator doesn't let you calculate that value, but what you do know is that the height at that given point is 0. So here's what we're going to do. We're going to take this equation right here, and we're going to set it equal to 0. Okay, I'm going to manipulate it a little bit so that we have from highest to lowest degree. So that means that we have negative 16t squared plus 240 sine 10 degrees t plus 5 equals to 0. Okay. Alright, this looks like a complete mess. Alright, so I don't know if I can factor this out. Completing the square is possible, but it's just going to be difficult. So I'm going to use the good old-fashioned quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And you might be looking at me like, are you crazy? That's going to be some insane algebra, but you have your calculator to help you out, and I'm going to show you a trick. First of all, we know that the a value for this is going to be negative 16. We know that the b value is going to be this entire thing here, which is 240 sine of 10 degrees. And lastly, we know that the c value is 5. Okay? So here's what we're going to do. Remember how your calculator has that awesome feature to store values? We're going to do just that. So we're going to say negative 16. You're going to hit STO. But instead of storing it on T, if you hit alpha and then you hit math, which is the letter A, every time you hit the letter A, you're going to get that value. Okay, so we're going to do the same thing, but now for B. 240 sine of 10 degrees. We're going to store in alpha B, enter. And lastly, we have 5 stored alpha C. So here you go. Every time you hit alpha A, you're going to get the negative 16. Alpha B, you're going to get that entire value. And alpha C, you're going to get 5. So here's how it is going to become. You're going to enter your equation on your calculator just as it is. So we're going to say alpha y equals enter to get a fraction. So x equals negative b plus the square root of minus 4 times a times c all over 2a. Cool? Now notice how the equation says plus or minus. Well, you're going to have to do this one at a time. So we're going to do the plus first. So when I hit enter, you get a negative number. Well, let's think about it. For this problem, does that make sense that I'm getting a negative number? No. So that means that I'm probably going to have to do the equation again, but instead of plus, I'm going to substitute it with a minus. Hit enter. Okay, alright. So that means, in this case, well, it's not x, we're going to call it t. I'm sorry, I have a t equals 2. So that means that the time it took to hit the ground is approximately 2.720 seconds. Okay? But I'm not going to approximate. I'm going to store the value into t, and then I'm going to go to the calculator, second calculate value. I'm going to hit t because I've already stored it, and I'm going to hit enter. So after 2.719 blah 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 seconds, you're at this point, which is 0 height, and that means that the longest distance, or the distance it traveled horizontally, okay, so that's part B, is 642.795 feet. And that took, the time that it took, it was approximately 2.720 seconds. Okay, I'm sorry, I'm totally out of the page. Alright, so it says assume, find the distance that it travels. So we found that. That was part B. Part C says use a graphing utility to approximate its maximum height. And then part D says to find the total time the arrow is on the air. Well, we actually kind of already did that, which is this part right here. So this is part D. This is part B. So part C says we need the maximum height. Looking at our diagram, it's going to be somewhere in here. Okay? Alright, so if the time it took to get from, looking at the calculator, from here to here was 2.72 seconds, so wouldn't the time to get to half would be half of it? So what I'm going to do is I'm going to, again, do the same thing I did previously. I'm going to divide it by 2, and I'm going to store that value on t. Then I'm going to go back and calculate that value. So when I hit enter, that's going to be approximately my highest point. And remember how I said approximately, it does, I'm not looking for something exact, but I'm looking something along this line. So the maximum height for this problem is going to be approximately 32.086 feet. Okay, and you can kind of give yourself an idea, because when we checked the table, it got to 30 something and then it started decreasing. Okay, so that's an approximation. Alright, so there it is, guys. That's how you solve this problem. That's how you can use the calculator. This is going to be on your quiz, so please study, and I hope I see you guys soon.